Okay, now we have a look at the second case study, which is at the back of the colour index prac, also called the false colour index prac. This time we're just asked to find as much information about one star. So here is the information from the Wikipedia entry on Rigel, or Rigel, or Beta Orionis as it is most commonly known as. So let's unpack all this data and see what we can do. So first thing here is we notice that the spectral type is a B8 and also 1A. Now remember, we need to be able to refer to external sources to be able to unpack a lot of these things, but this we know is a B class star, and it's B8 means that it's a B getting towards becoming an A star. So it's closer to an A. So if when we're having a look at it, remember it goes A0 there, then it goes F class next is F0, so it goes F all the way up to 9, then becomes F0 up to F9. So this is B0 here, going up to B9. And so we can determine that we are about here in the class wall. In the class between the two. Okay. Now, knowing that, we can determine a few things. If we know that it's a B8, we can work out the temperature, okay, of the star. That's a surface temperature. We also can work out the colour and the colour index of the star from that. Well, we're actually given the colour index. The colour index is negative 0.03. So we know that the colour of this star, because it's nearly approximately 0, is white, which makes sense because these colours here in this section are all white. So let's have a quick determination of the temperature. So to do that we need a colour index or a spectral class table. So let's go and see if we've got one which is a, let's just get rid of all this stuff here. Here is a Hertzsprung-Russell diagram, and we are given that it's a B8 star. So we know the B stars are around about 10,000 Kelvin. So we're not being very accurate here, but out of memory, it's about 10,000. But we know that if we can do it with a colour index, it'd be much more accurate, okay, because it's 0.3. So we know it's a B8, it's about 10,000. And there is the colour index. But we want to be a bit more accurate than that, so let's see if we can find a more useful chart. And here we are, a colour index against temperature. We know that we are looking at approximately negative 0.03 colour index. So looking at that, it's around about there, so it's giving around about 9 to 10,000 Kelvin again. So it's approximately 10,000 degrees Kelvin. Okay. So we know that it's a B class, so a B8, therefore it's going to be white in colour, and it's going to be that temperature. Right, so that's the first thing. The second is the luminosity class, which is a 1A. A 1A means it's a member of the luminous giants. There are two classes of 1A and 1B, okay, and these are the superluminous giants. So if I was to having a look at the Hertzsprung-Russell diagram, it's a 1A, and therefore it would be up here, right up here. It's a very, very bright star, so we can also determine that its absolute magnitude is around about negative 7. So just simply using that, where are we? Oops, wrong. Which one? I'll go back to that one there. So we can determine that from this here, the absolute magnitude is negative 7, approximately. Okay. So just looking at this one alone, plus a little bit of this one here, we can say the following. B8, we can say its class is B, its colour is white. We can use that with both of the colour index as well as that. 1A, we can label it as a superluminous giant. by using the Hertzsprung-Russell diagram, we can determine that it has an absolute magnitude of -7 using these two pieces of information. Okay, so that's the first two. Now, what else can we do with the next bit? So just clearing that. So let's say that we have determined that its absolute magnitude is -7. We can now work out how much it would appear to us be given the distance, because we know that the distance is equal to 10 times 10 to the m, take capital M, on 5. So this is a distance modulus formula. So given the distance and the absolute magnitude, we can determine the apparent magnitude. So from this information here, I can work out the apparent magnitude m. Now the formula for determining the absolute and apparent magnitude is given on the formula sheet as m, capital M, equals m minus 5 log d on 10. So little m would equal capital M plus 5 log to the base 10 d on 10. So that would be -7 plus 5 log, so just get my pen to work, log d, which is 260 on 10, in other words 26. Just typing that onto our calculator, we get 5 log 26. That equals 7.707, times that by 5, and it's -7 plus that. Therefore, the apparent magnitude would be 28. I think I made a mistake there. Just let me check my calculator. Yeah, as I thought, I just used the wrong finger. It comes out to be 0.07, which is approximately 0.1 apparent magnitude. Okay, so if we were to have a look at that on our Hertzsprung-Russell diagram, what does it appear like? Remember, this is apparent magnitude. So it appears quite bright. Remember, up here are bright magnitudes, and down here are the dim magnitudes. So it's approximately 0. So it appears as if it is one of these stars here, but in reality it is much brighter. It is up here. Okay, so that's the first thing that we can do. So we can, from the distance, what else can we use the distance formula for? Well, we can also determine its parallax angle. So just clearing that, we know that the distance equals 1 over the parallax angle, and therefore parallax angle would equal 1 over the distance. So it's 1 over 260, and so if you do that into your calculator, you get its parallax angle be 0.00, and we'll just go 4 there, it's actually 3/8 from there, arc seconds of arc. Okay. Oh, I just noticed that the next one down here is the absolute magnitude. I wasn't even looking at that one yet. We've been using so far the absolute magnitude as -7. We know that it's -7.84, so that last calculation could be even more accurate than my estimate of -7. Okay, so far what have we discovered from this information? From the spectral type up here, we've given the fact that it is a B8, so therefore it's a hot large star. The 1A, it's either larger than that, it's a superluminous blue star. Sorry, white star. Colour index, we can get the actual temperature. We know that its surface temperature is about 10,000, and the distance, using that one here, and a few moments ago I used the absolute magnitude of -7, I should have used that one. We can work out its apparent magnitude. Okay. Is there anything else that I can determine? Well, yes, I can actually work out what are some of the spectral features of a B8 star. So let's take a few moments and get that chart up. Okay, so we have this chart, which we know very well. We know that it's a B8 star, so it's closer to the 10,000 than for the 28,000. So B8 star would be here. We know it's a blue-white. These are the spectral features. We have neutral helium lines, and we have medium strength Balmer H lines. We also then know, just offhand, this size in comparison to our Sun, that it's around about, remembering it's a B8 star, so it's closer to the first one here than the second one. So it's about 3 times to 5 times the size of our Sun. It's got about 3 to 5 times the radius of our Sun, and its luminosity is around about 100 times brighter than our Sun. And it also has a lifespan of around about 10 to 15 to 20 million million years, not million light years. Okay. We can also use the information that we have got from the absolute magnitude. Let's go back to our absolute magnitude here. The absolute magnitude of this star is negative 7.84. Okay, so if I've got negative 7.84, and using the Hertzsprung-Russell diagram, negative 7.84, we can determine just on this side the luminosity in comparison to the Sun. So we know that it's about 100,000 times as bright as the Sun. So we have a huge amount of information that we've got just from this information alone. Okay, I hope this helped. I hope you can have a practice on doing another Wikipedia entry. Just go to any star that you know. We might want to try Aldebaran or some other star. Just do a Google search of some common stars, and just have a look at their summary on the Wikipedia site. On the website, there's a whole summary just on the right hand side here, and you can have a look at these things and say, okay, what can I glean from these information? Okay, thanks very much.